Unit 5, Similarity, Lesson 5, Similarity Transformations. Your objectives for this lesson are to identify similarity transformations, to use ratios to verify similarity transformations, and to draw dilations. Okay, so the word transformation should be familiar from back in Unit 2, I believe. But we looked at rigid transformations back then. Now we're looking at a different type of transformation. We're looking at dilations. A dilation is a transformation that enlarges or reduces the original figure proportionally. When you have dilations, you have a scale factor, which is abbreviated with the letter K, and this is the ratio of a length on the image to a corresponding length on the pre-image. When K is greater than 1, the dilation is an enlargement. So greater than 1, you're going to get a bigger picture. Bigger number, bigger picture. When K is between 0 and 1, so it's some fraction or decimal, the dilation is a reduction. So smaller than 1, smaller picture. If you're still confused about what a dilation is, let me demonstrate this here. I have a star right here. Okay, and I'm going to clone the star, so I now have two identical stars. Well, in a dilation, I could enlarge it like this, and you can see they're still the same shape. They're still proportional, but this one's bigger. So this would be an enlargement. Or I could have shrunken it down, and that would be a reduction. So enlargement, reduction. Example 1. Determine whether the dilation from A to B is an enlargement or a reduction. Then find the scale factor of the dilation. So we have part A here, and you can see A and B. I'm going to highlight B. So this is our image. A is the pre-image. We're moving from A to B. We want to know, is this an enlargement or a reduction? Well, is A bigger than B or smaller than B? It's smaller. A is smaller, B is bigger. So this is an enlargement. And that's pretty easy to tell. But now we need to find the scale factor. So what I'm going to do, I'm going to write a ratio. So on A, this length here is 2 units long. You can see 1, 2. So I have 2 on A, goes with 1, 2, 3, 4 on B. Okay, really that should be switched around though. Sorry. So 4 over 2. And that simplifies to 2. Now the reason that I switched that around, I know that my scale factor, my K, needs to be greater than 1 because this is an enlargement. So if I had done this the other way, I would have ended up with 1/2, which would tell me that's a reduction. It's not. So you always want to put the new over the old when you're figuring out the scale factor. And in this case, our scale factor is 2. So I'm going to say K equals 2. Where's part B? There it is. Okay. Part B. Again, moving from A to B. And you can see that B, this time, is inside of A. So B is right here. So this time we have a reduction. It is smaller. How much smaller? Well, I'm going to look at these sides over here on the left. My new, remember we're going to do new over old. So my B, 1, 2, 3 units over, for A, I have 1, 2, 3, 4, 5, 6 units. And this simplifies to 1/2. I know that 1/2 is between 0, and 1. So that's good. It should be for a reduction. So k equals 1/2 is my answer here. Okay. Example 2. Graph the original figure and its dilated image. Then verify that the dilation is a similarity transformation. So first thing I need is some graph paper. There it is. So we can graph the image and the pre-image. So A is at -3, 4. B is at 2, 4. And C, -3, -4. Okay. So this is my pre-image, triangle ABC. And now our image, we have D, E, F. So 1, 0, 3.5, 0, 2, 3.5, 0, and 1, -4. And I think you can tell without me even connecting the dots here that this is a reduction. Okay. What do we have to figure out here? Oh, verify that it's a similarity transformation. Okay, so basically we want to find the ratio between each of the side lengths and make sure that each one is proportional. Remember, in two similar triangles or two similar polygons, all the sides will be proportional. So let's find the length of each side first. I'm going to say AB, I'm just going to count these. 1, 2, 3, 4. This is 5 units. AC, I have 1, 2, 3, 4, 5, 6, 7, 8 units. Okay. BC's a little bit harder. I have to use the distance formula here. So distance formula for BC. My distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I have x, y, x, y, 1, 1, 2, 2. Okay. So I'm going to have -3 minus 2 and -4 minus 4. Plugging them in. And I get square root of -5 squared plus -8 squared. So this is the square root of 25 plus 64, which is the square root of 89, which isn't really a pretty number, but we'll let that be. Let's count these ones. So DE, I have 2.5, it looks like. DF, 1, 2, 3, I have 4. So what is EF? I'm going to have to use the distance formula again here. So let's label x1, y1, x2, y2. I'm going to have 1 minus 3.5. And -4 minus 0. Okay, so this is -2.5 squared and -4 squared. I'm not really sure off the top of my head what negative 2.5 squared is. 6.25. And that's a 16. So what is 6.25 plus 16? We have the square root of 22.25. Okay. And now we're going to go ahead and set up we're going to set up our ratios and see if they're all equal. Okay. So AB I can see pretty clearly goes with DE. So 5 over 2.5, and that gives me 2. AC goes with DF, so that's 8 over 4, which gives me 2. So these two are good so far, but I want to make sure that the square root of 89 divided by the square root, I said, of 22.25. I want to know that that equals 2. And those are some really nasty, ugly numbers. So let's check that. So we have the square root of 89 divided by the square root of 22.25. Oh, good. Good. We have a 2. Okay, so since we have 3 2's here, that's a check. So, yes. And we're not going to do part B because that was too long. Okay. But basically the gist from part B is you can do this with other shapes, not just triangles. You'll see I have 4 vertices here. If I had 15 vertices, I could still do the same process. Example 3. This triangle has the vertices A, -2, -2, B, 1, -1, and C, 0, 2. And we're going to draw the image of ABC after a dilation with K equals 2. So first thing we need to do is plot these points. So A is at -2, -2. B is at 1, -1. And C, 0, 2. Okay. Let's connect these. And this, I promise this is easier than that last problem was. Okay. So when we're dilating on the coordinate plane, this is actually a very simple process. Find your scale factor, and you're going to multiply each coordinate by the scale factor. So A is -2, -2. A prime is going to be the scale factor 2 times that -2 that we had, comma, 2 times -2. So this is your scale factor. You're just multiplying. So we get A prime is -4, -4. Okay. B prime. So B is at 1, -1. B prime, we're going to have 2 times 1, comma, 2 times -1. So we have B prime at 2, -2. 2, -2. So we have A prime, B prime. Okay. And last, C prime. So C is at 0, 2. C prime, going to have 2 times 0, comma, 2 times 2. So we have C prime is at 0, 4. That's a little off. Okay. And now we can connect these. and you see the new dilated, enlarged triangle. And it should be an enlargement because our scale factor was greater than 1. It was a 2. So pretty simple. Example 4. Draw the dilation image of ABC with center O and K equals 2. And you'll notice this time that we're not on the coordinate grid. We're going to have to do this a little bit differently. So K is still 2, which means that we still have an enlargement. But this time I'm going to need a ruler. I don't want that. Okay. And I'm going to use the centimeter side of my ruler here, if I can get it to cooperate. Wait, there we go. Okay. And the first thing I'm going to do is measure the distance between O and each of these points. Maybe I should actually... I'll use centimeters. Okay, so I'm going to start by measuring the distance between O and B. And I see that that is about 3.3 centimeters from O to B. So OB is 3.3 centimeters. Since K is 2, I'm going to multiply this by 2, so 3.3 times 2 gives me 6.6. And now I'm going to draw a segment that is 6.6 centimeters long. So that's right there. And I'm going to connect it. Well, I guess I don't have to connect it. That's just my B prime. You could connect it with a line segment if you weren't sure of your placement. That's B prime. Okay. Next, I'm going to rotate my ruler down to C. And I can see that from O to C, that's about 4 centimeters. So OC is 4 centimeters. So I'm going to say 4 times 2, again, this is my K, gives me 8 centimeters. And I'm going to put a point at 8. So this is C prime. And last, I'm going to do A here, and we're a little less than 3 centimeters. I'll call it 2.9. So O, not OC, wow, OA is 2.9 centimeters. And then 2.9 times 2 is 5.8. So 5.8, and I have my A prime. Oh gosh, let me move this ruler out of the way. And then once you have your 3 points, all you have to do to finish up this enlargement is connect the dots. And so really drawing dilations, even off of the coordinate plane, isn't too terrible. You've had worse constructions with me. Okay, so there we go. Triangle A prime, B prime, C prime. And that is the end of lesson 5.